Hey there, everybody. We're going to be doing a BC Calculus FRQ question for you all today. And also keep in mind that there are going to be no calculators allowed on a question like this during the test, so don't be the idiot that uses them. And the equation we will be using today is the Maclaurin series of the summation of n times 2x to the power of n minus 1.
Hi, to begin 6a, you'll need to find the interval of convergence of the Maclaurin series for f, and then you'll need to justify your answer. So first step, you'll need to change the equation n 2x to the n minus 1 into n 2xn all over 2x. Then you'll need to test the interval of convergence on the series. And in this case, we'll use ratio test. After conducting the ratio test and canceling out terms, you should end up with the limit as n approaches infinity of 2x times n plus 1 all over n. Then you'll need to solve the limit, and you should end up with x is greater than negative 1/2 and less than 1/2. Now we need to test the endpoints to find whether the endpoints converge or diverge. After plugging in negative 1/2 into the original series, you should end up with the limit of n approaches infinity of n times negative 1 to the n all over negative 1. The series diverges by the nth term test because the limit as n approaches infinity does not equal 0. After, you'll need to test the positive 1/2 in the original series as well. And you should end up with the limit as n approaches infinity of n times 1 to the n all over 1. The series diverges here by the nth term test because the limit as n approaches infinity does not equal 0 as well. To conclude, the limit as n approaches infinity of n times 2x to the n minus 1 converges when x is greater than negative 1/2 or less than 1/2.
Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed.
Okay, so you're given the Maclaurin for f of x, gives you that equation, those first three terms, and it just wants you to find f of x squared, and the first three terms for that and the new equation. So literally all you gotta do is plug in x squared for x. So the new equation is n times 2x squared to n minus 1. The first term stays 1 because there's no x. The next term becomes 4x squared. And the next term becomes 12x to the fourth. And yeah, that's all you gotta do. Thank you.
She was looking kind of dumb with her finger and her thumb in the shape.
I don't know how I should do my introduction.
I don't know what I'm supposed to be doing during the video.
Oh well. Hey there, everybody. We're doing some calculus here. This is going to be part C. So, the question, it says, find the first three non-zero terms and the general term for the Maclaurin series for the function h, given by h of x equals the integral from 0 to x of f of t dt.
Of course.
And joining me today is Griffin Channer, because
I don't know what's happening.
I hate recording videos by myself.
And I don't know what's happening. So.
Yep. So, first step is going to be just taking the integral of the first three terms, which is these, because we're going to find those first three terms. So, it'd be from 0 to x, that's about x, of 1 plus 4x plus 12x squared. Wait, no, these are supposed to be t's, so that's a t, and that's a t. Just ignore that, those are t's.
I'll be sure to ignore that.
dt. Alright, and so we're just going to do some simple calculus here. So it'd be t plus 2t squared plus 4t cubed from 0 to x, and that will become x plus plus 2x squared plus 4x cubed. And those are the first three terms of the series for h of x. Alright, sorry about that, guys. I had to cut the video real quick because I screwed up. So, now what we're going to do is find the general term for h of x. So we're going to take the integral of the general term right here of f of x, it'll be of f of t. So let's do that. That's a great integral sign. So from 0 to x of n times 2x to the n minus 1 d, or you know, I'm really hating this right now. This is going to be a t, and hold on, okay, t, and then dt. So what we have to do is we got to do u sub because it's got an inner. So this will be u equals 2t du equals 2 dt, and then du over 2 equals dt. I'm not going to write that. So now we have the integral from 0 to x of n times u to the n minus 1 du over 2. Now what this will do is we're going to take the integral of this, and we'll get so we'll add 1 to the exponent and divide by the new one, so it'll become n, and then divide by n, so that n will just go away, and we'll get u to the n times 1/2 from 0 to x, and then we're just going to plug back in the 2t for the u, and we'll end up getting 2t to the n times 1/2. Well, that's supposed to be a bracket from 0 to x, and then that'll become 2x to the power of n over 2, and that is our general term for h of x. So h of x will end up equaling, that's a great thingy, n equals 1. And this is our general term for h of x. So here we have the thing for our final answer. We have x plus 2x squared plus 4x cubed is our first three terms, and this is our general term. So thank you for watching part C of this video, and here comes Quinn with his part that he hopefully recorded. So
Heyo!
Oven out on her forehead. Well, the issue.
Part D asks you to find the value of h of negative 1/4 using the Maclaurin series from Part C. So the first step is to write out the Maclaurin series for h of negative 1/4. And we know this is a geometric series because we found the formula in Part C, which is 1/2 times 2x to the n. So since this is a geometric series, we can use the formula for a geometric series, which is a over 1 minus r, where a is the first term and r is the common ratio. Using this, we can find the first term for h of x by plugging in 1 for n. If we do this, we get 1/2, a equals 1/2 times 2x to the first, which equals 2x over 2, and that equals x. And we already know that r equals 2x. So from here, we can plug in our values for a and r into the formula, and that gives us x over 1 minus 2x. So this is the formula for h of x. Now, all we have to do from here to get the value of h of negative 1/4 is to just plug in negative 1/4. And if we do that, we get negative 1/4 over 1 minus 2 times negative 1/4, which equals negative 1/4 over 1 plus 1/2. And if we simplify that down, we eventually get our final answer of negative 1/6.
Start coming and they don't stop coming. Fed to the rules and I hit the ground running. Didn't make sense not to live for fun.
Thanks for watching, everybody. Don't forget to smash that like button and subscribe, and tell us what you think about the video in the comment section.